Hello everyone, I'm Nikolaj Frost Jacobsen, Director of Machine Learning at Corti. In this short video, I'll walk you through how to interact with our streaming API from authentication to real-time transcription and fact extraction. Whether you're building a clinical assistant or integrating AI into your platform, this demo is meant to show you how easy it is to get started. Let's start with a high-level view of the full interaction. First, we authenticate using Keycloak. Then, we create an interaction session via our API. Next, we connect to a WebSocket and send a configuration message. After that, we can now stream audio in real time. As the audio is being processed, we receive transcriptions and facts. Finally, the session ends gracefully, giving us real-time insights into the call. I'll walk you through each step with code examples. Healthcare data needs to be secure, and security is something we take very seriously here at Corti. That's why access to all our APIs is protected through secure authentication endpoints. This documentation page walks you through the process of authenticating with Corti's platform, step by step. We use OAuth 2 with client credentials grant type. This allows server-to-server communication using a client ID and a client secret. When you sign up for API access, we'll provide your auth URL along with the necessary credentials tied to your tenant and your environment. Now, let's take a look on what this looks like in Python. Before we dive into the code, a quick note on security. To avoid hard-coding secrets, we store our client ID, client secret, and tenant name in a .env file. Then, we use python.env as seen on line 12 to load those credentials safely into our script. This keeps sensitive data out of version control and makes the code cleaner to manage. Now, here's how we implement the authentication flow. We define a function called getAccessToken as seen on line 18, which does three things. First, it constructs the authentication URL dynamically using the environment and tenant name. This ensures that we hit the correct authentication server. Second, it builds the payload on line 21 with grant type set to client credentials, our credentials loaded from the environment, and the scope set to OpenID. Finally, we send a post request using requests, and if it succeeds, we extract and return the access token from the response. This token is then used as a bearer token in all subsequent API calls, like creating interactions or connecting to the WebSocket. It's a lightweight and secure way to authenticate programmatically. Once authenticated, the next step is to create an interaction. An interaction represents a clinical conversation, and this is what you'll stream audio into and receive insights from. The interaction is created using a simple post request to v2/interactions. The payload includes information about the encounter, such as a unique identifier for the encounter, the type of consultation, that could be first consultation, the status, usually planned, and the start-end time of the session in UTC. Optionally, you can also assign a user ID or additional context specific to your use case. Once an interaction is successfully created, the response will include two important things: an interaction ID, which uniquely identifies the session, a WebSocket URL, which you'll use for real-time audio stream. Let's look how this works in Python. In code, the interaction creation is handled by the createInteraction function. First, we prepare the post request. We'll set the URL using the environment name and include the bearer token and tenant name in the headers. The payload includes an assigned user ID generated as a UUID and the encounter block. Inside the encounter block, we generate another UUID for the identifier, and we specify the encounter type, here it's the first consultation, its status as planned, and a time period with both started at and ended at set to the current time in UTC. This structure allows us to simulate a real consultation session with proper metadata. If the request succeeds, we return the full response, which contains both the interaction ID and the WebSocket URL. We'll use that WebSocket URL in the next step when we establish the real-time connection. Now that we have our interaction set up and a WebSocket URL in hand, it's time to open a real-time connection. This is where the real-time magic happens. The WebSocket endpoint provided by the interaction is what we'll need to connect to. And once connected, we need to send a configuration message. The setup on the configuration message can be seen here. This config defines how the audio should be processed. In our examples, we will specify the primary language, in our case English, that it is a single channel stream, we'll set is multi-channel false, and that we're not using speaker diarization. Under the mode, we set the processing type to facts and choose output locale as English. This tells Corti, listen for clinical facts in English from one speaker in a single audio stream. Once the config is accepted, we're ready to stream audio. Let me show you how we implemented that config step in Python and how our config looks like. In our Python code, we define an open function as seen on line 78. This is triggered as soon as the WebSocket connection is established. Inside it, we send a JSON message with the config I just described, transcription options as one block, and processing mode as another. We then pass that config into the live WebSocket using ws.send. If everything is valid, the server responds with a config accepted message, which is our signal that we can begin streaming audio. This gives you full control to shape how your stream is processed based on your use case. Once our coding config is accepted, we move on to step 4, streaming audio. This step is all about sending audio data to Corti over the WebSocket connection in real time. In our case, we're streaming from a .baw file, but this could also be integrated with a live microphone feed or a call recorder in a production setup. The audio is read in chunks. Here we use 32 kilobytes per chunk, and we send each one using the ws.send marked as binary data. Between chunks, we pause briefly to simulate real-time playback. This keeps the stream from flooding the server and mimics live conversational pacing. Once the entire file is sent, we signal the end of the stream with a final message, type end. This tells Corti that no more audio is coming, and it can wrap up processing and send back any remaining results. With audio now sent, the next thing we listen for is real-time output, transcriptions, and facts. Step 5 is where you start seeing Corti in action, receiving live transcripts and clinical fact as the audio is processed. These messages arrive over the WebSocket in real time while the session is still active. You'll typically receive 2 types of messages. First, the transcript messages. These contain the spoken content transcribed in near real time. In our code, we collect these into a list and print them once the session ends. Then there are fact messages. These contain structured insight extracted from the audio, for example, symptoms mentioned, medication prescribed, or assessments made by the clinicians. You can pass these messages and feed them into your application, whether it's for documentation, decision support, or quality control. At once Corti sends an ended message, we know the session is complete. At this point, you've got both the transcript and the facts, and you've reached full stream processing. At this point, we walk through each step of the pipeline, and now you've seen how to stitch it all together. You start by authenticating securely. Then you create an interaction. We've done that here. Next, you open the WebSocket and send your config. We connect here and send the config. Finally, we can start receiving the transcripts and the facts. The Python code brings all of this into a single flow. Each function handles a specific step, making it modular, testable, and easy to integrate into larger systems. You can use this as a starting point, whether you're building a prototype, integrating with an EHR, or developing real-time clinical tools. And the best part, you're in control of the experience. You decide what to stream, when to start, how to process the results, and where to take them next. Corti's API is designed to be flexible, and as you've seen, getting started takes just a few lines of code. So let's quickly recap what we've done in this walkthrough. First, we authenticated securely using Corti's authentication setup. Then we created an interaction that defined the session context. We connected to a WebSocket, sent a config, and streamed the audio in real time. Finally, we received transcripts and extracted clinical facts, live as the session unfolded. You now have all the tools you need to build with Corti's streaming API, whether it's for real-time documentation, ambient scribing, or advanced clinical support. If you want to dive deeper, you can check out the full Corti API documentation, get your access credentials by reaching out through the developer portal. You can also grab the code that I used here in the demo from the pastebin link, and you can get started right away. All these links will be attached to the video. This is just the beginning. You can use this foundation to build all kinds of powerful healthcare applications. I look forward to seeing what you will build.